warm welcome to Muneeb of Blockstack. Yeah.
Hi, everyone. I'm Muneeb, and with my co-founder, Ryan, today we are going to tell you about Blockstack, a new internet for decentralized apps. Those of you under 30, this used to be the Chrome in the 90s. And when this browser came out in '94, that was like a magical moment, because the internet before that was so hard to use and so complex, and this was actually hiding a lot of that complexity and opening up the internet to a wider audience. I got obsessed with this technology back then, ended up doing a PhD in computer science, focusing on internet infrastructure. So today, I'm going to tell you guys a little bit about how the internet works and what are some of the ways in which it's broken. So let's say you connect to online and you want to send a message to your friend. Usually you'll end up using some service like Facebook. So you connect to Facebook, your friend connects to Facebook, and now you guys are chatting on their servers. What most people don't realize is that in that connection, there's a long list of third parties, these companies and these third parties that you're blindly trusting, and you don't even know that they exist. And they include like domain name servers or certificate authorities. For example, recently in Turkey, a certificate authority was issuing certificates for Google, which were false, which meant an entire country thinks that they're talking to the right Google, when actually they're not. So the first problem with the internet is that we blindly trust these parties that we don't even know exist. And if you do connect to the right party, if you do connect to the right Google and the right Facebook, then the users are giving all of their data to these companies. And they're dependent on these large companies to be able to use the internet in the first place. So the second big problem with the internet is that users actually don't have ownership of their data. These large companies do. And this doesn't just apply to users. It also applies to developers as well, who now have to ask permission from these large companies before they can actually innovate on top and build applications. Twitter is a good example of this. Like in the early days, the ecosystem actually had lots of different clients and applications, and then slowly Twitter started shutting them down. The most recent example was actually Meerkat, which was an app that was going viral, and then Twitter bought a competitor and then shut down that application from using their data. We want an open internet. Google has this saying that don't be evil. But maybe it should be can't be evil. Maybe a company shouldn't be powerful enough that they're sitting there thinking, should I be evil or not? So if you're building a new internet, if you're saying that let's go ahead, let's start from scratch, let's build a new thing, how should it be different from the old internet? We should think about how in real life, people have property rights. You can actually go and buy a house. You can put all of your belongings in that house. We don't have that concept online. We're always renting space from other companies. And the fundamental thing that blockchains do is that they enable you to finally have digital property. You can actually directly own something online. And at Blockstack, what we are doing is that we are building an internet based on that principles. So you can actually directly own your usernames, your profiles, your data on a new internet. But blockchains have a lot of scalability problems. So first thing about blockchains that most people should realize is that they're not a general purpose database. You cannot just put all of your data in a blockchain, any blockchain, and expect that to work. So we believe that we should only use blockchains for critical important data, like ownership information and some pointers to other things, and move most of that complexity out of blockchains. Similarly, blockchains are not general purpose computers. This idea that you can actually have a world computer where all the computations for the entire world are actually running on a blockchain is a fantasy which would be very hard to implement in real life. And we believe that we should move all complexity out of the blockchain. And this is not just for scalability, but also extremely important for security. And we should think of like how there are laws of physics and all computer systems absolutely need to conform to those laws. Similarly, there are laws of distributed systems, and all blockchains have to comply to these limitations. And we should design systems that actually work with these limitations instead of thinking that they don't exist. Similarly, in any decentralized internet, usually you would end up having some sort of a peer network. So you're not going through companies anymore, but you're actually directly connecting to other users. For a peer network, you have to be able to give performance that is similar to cloud computing. Realistically, users are not going to switch over to a decentralized internet if the performance is actually worse than what they're used to with the traditional internet. And with these peer networks, the key problem that we need to focus on is actually discovery of data. So most BitTorrent-like protocols are basically using one variant or the other of the same protocols and algorithms, and most of them are actually pretty bad at reliability, and they don't scale out. So at Blockstack, we've actually been working on these problems for a while. We have a new internet running, like a second internet, a parallel universe, for over 3 years now. And there have been 70,000 domain names registered on that internet. So imagine that if you install the Blockstack software, you have access to the traditional internet where you're dependent on these root servers and these big companies, or you can connect to the decentralized internet and talk to the blockchain name system, or BNS, and use decentralized applications. Last year, we introduced this technology called virtual chains. And what it does is that it lets you build blockchains on top of other blockchains. This is very similar to what happens in data centers these days, where all of your apps and services are actually running in virtual machines. And what that does is that if the physical machine that your app is running on actually fails, you won't even notice it, because you can migrate over to something else. We have done the exact same thing with blockchains. We believe that it's too early to actually pick a winner, that this blockchain is going to be successful or that blockchain is going to be successful. But the apps and networks built on top need to outlive any underlying blockchain. And this is what we get with the virtual chain technology. We've also released a new Atlas network, which is an unstructured peer network that gives you full replication. What that roughly translates into is that we have solved that key problem of data discovery. Once you can discover data in a reliable way, you actually have a realistic shot at building a decentralized internet that actually gives you reliability and performance. And finally, we have released a Gaia storage, which is a decentralized storage system that follows the design principle that we should reuse existing infrastructure. All these data centers, all these content distribution networks that have already been deployed, we can actually reuse them in a way where we can still, the end user gets the experience that is still decentralized. Because we put encrypted data on these cloud providers. These providers have no visibility into the user data, and the user is actually not dependent on any single provider. The really important thing over here is that this gives you the best of both worlds. It gives you the performance of cloud computing, and at the same time, it gives you the decentralization properties of peer networks that we are so interested in. We have actually published these in peer-reviewed computer science conferences, and you can get more details on our website. Now I'm going to switch over to my co-founder, Ryan, who's going to tell you a little bit about the usability issues of the early internet compared to the decentralized internet, and then we have some really exciting announcements for you guys.
Hi, everyone. So I'm Ryan Shea, and I'm here to talk to you about browsing the new internet. So the early internet, before we had a lot of the applications that we know and use today, the early internet was very, very difficult to use. And the problem is that core pieces were missing. One, the right tools for building consumer apps, and two, a friendly interface for consumers. In 1984, the first domain name server was released. And this allowed you to type in a name into your computer and know how to connect to another computer anywhere else in the world. In 1994, the first web browser was released for widespread consumer adoption. And this was Netscape. And for the first time, consumers had the ability to look into the internet, to actually go into their browser bar and type in something and visit a website and experience applications on the internet. Then in 1995, new tools like JavaScript and SSL were released, which unlocked a whole new range of applications. It allowed for much more rich and secure applications. And this is the foundation upon which the applications that we use today have been built. These were all critical components of the internet that we know and love today. Now today, the decentralized internet, the blockchain-based internet, is very, very raw and very hard to use. Just look at the fact that there aren't really any applications for widespread consumer use. The closest thing that we have is some level of speculation. Now, the thing is, again, the core components have been missing. One, the right tools for building decentralized apps. And two, a friendly interface for consumers. So in 2014, we released the first decentralized identity system built on the blockchain, along with a naming system where you could actually have an identity and a name that you are completely in control of, which is in sharp contrast to the existing identity systems where you really rent your identities from Google and Facebook and Twitter, and where your domain names are actually owned by companies like VeriSign and organizations like ICANN. And you're also just renting property from them. Then in 2017, we've released some core libraries and services for developers to build decentralized applications, which include identity, storage, and payments. And all of these things are tied into user-controlled identity, user-controlled data, and user-controlled money. It's a sharp contrast from the existing world in which all of our data and all of our identity is locked up in data silos by individual corporations. And then today, we're excited to announce the release of the first true decentralized internet browser. This is the Netscape of the new decentralized internet. And you can go and you can download the developer release today. So we're doing something very similar to what Apple has done with its operating systems, where we release an early developer release. You can download it if you'd like, but it's primarily for developers. And developers can build applications on this. And then months later, we will release a wider consumer release. But this is a new browser where you can actually manage everything on your own device. You have an identity that you completely control. This is not, again, this is not under the control of Facebook or Google or Amazon. It is under your control, and you own it with your own keys on all your devices. You control your data and your storage. It's on your device, it's encrypted, and it's synced up to your cloud storage providers. And cloud storage providers are completely commoditized. You own your money. It's just with simple keys, any blockchain-based currency, you can own it and use it on this browser. And all happens with the keychains that are stored across your devices. And then you can go and take these user-controlled resources, your identity, your money, and your data, and you can bring it to an application with you. You can try logging in to a sample application. You can log into any one of these decentralized applications on this new internet. And many, many more applications are coming. And soon, you will also be able to type the name for your application directly into your browser bar. This is a true end-to-end decentralized internet. You need all of the components to bring a full consumer experience. Now, the next thing I want to talk about is how the decentralized internet has scarce digital property. So for example, namespace, the names that we register, you're familiar with domain names or Twitter handles. that is actually a scarce resource, at least the names that are highly desirable. There's still an infinite number of names that can be registered, but the good names are very scarce. And the other thing is that blockchain space is very scarce. So whenever we have a scarce resource, we need some mechanism for distributing it. And this mechanism, traditionally in the blockchain space, has been a token. So you can use Bitcoin, you can use Ethereum, you can use Zcash. All of these are tokens that allow for the distribution of resources on blockchains. Whether that's blockchain space, whether that's namespace, whether that's the right to do an operation. All of these tokens have a resource distribution mechanism, a spam protection mechanism, and they're very critical for the operation of any decentralized resource allocation network. So with Blockstack, we thought about this and we said that the token that we're using must have a few properties. One, it's always been our philosophy that we should operate on the most secure and stable blockchain at any given time. We want the ability to migrate from blockchain to blockchain because who knows, decades from now, the blockchains that we have today might not be the blockchains that we have tomorrow. And we need the ability to be able to move and not be completely coupled to any individual blockchain. And the second thing is that these blockchains need to, the token that we're using needs to enable property transfers with very robust features and very interesting programmable logic. Like, for example, the ability to do an atomic swap for a name and a token. And with this in mind, what we've come up with is a Blockstack token. Today we're announcing that we're going to come out with a Blockstack token for this new decentralized network. And this is a token that will be shared by the entire network. And we're going to have a system where it can actually allocate the token using a layer 2 mining system. So this is not an ICO on Ethereum. This is not just another one of the tokens that you've been hearing about recently. This is a true new system on a different blockchain that operates as a virtual machine type chain, a virtual chain on top of existing blockchains. And this is a system that can transcend individual blockchains like Bitcoin or Ethereum or Zcash. So with this new token, you can actually access the decentralized internet's scarce digital property. This is a way for you to register names for applications, register names for people. You can register an identity without a name. It's absolutely possible. But there's a lot of social features that are required for names to allow you to discover. So this Blockstack token really fuels the new decentralized internet. So we're announcing the Blockstack token today. Much more information will be released soon. And you can go to get updates at blockstack.org. Get updates at blockstack.org. So thank you very much. We're here to announce the Blockstack browser and the Blockstack token. Go to blockstack.org today, check out the browser, get updates on the token, and thank you very much.
Thank you, Ryan.